All right.
Amen.
So let's begin today's session. Last week we looked at, or we started looking at the elements or the basic elements in programming, with emphasis on the C++ programming language. We spent time to look at the integrated development environment, which is the IDE. We looked at different examples of IDEs, talked about the editor, the compiler, the debugging, and the console, okay, for some selected IDs. And so today we want to finish chapter 3, and also supplementary material has been shared, or I've shared a supplementary material in the chat. Okay, at the moment, let me do save on the Classreps page so that you can use that as a supplementary material for the handout in case you have any struggle understanding it. Okay, so today my emphasis will be on that material which I shared, titled Basic Programming Elements. Just a moment. All right, so let's continue. So like I said, my emphasis will be on the document that I shared in the chat. So if you can't locate it, just go into the chat. The chat I shared it not long ago. Let me drop it for the class reps too, so that they can also share it. Just a moment. All right, so it's on the class reps page. Class reps, kindly share it to your respective classes. Okay, so last week we looked at some of the elements. We took a sample code. Over here, we explained the code, talking about what the code is about, and then trying to break it down to the element. Okay, now we went further to look at the elements, starting with the comments. We said the comments are basically parts of every program, okay, or every program comment. Now, these comments are there to describe what the program is about and also who the program belongs to. And we also said that the comments are not compiled. They are only there to guide the person reading the code. Okay, so we looked at the two types of comments. We said there's a single line comment, and then we also look at the multiple line comments. Okay, the videos have been shared on the class reps page. That's a YouTube link. Okay, so kindly watch it if you miss the class or if you miss the portion of the session of the class due to internet connectivity. Please go back and watch it. Okay, so we also talked about the special symbols where I think in the program example, we saw the special symbols in the color red, which are also part of
we can't hear you.
The elements with the special symbols. We talked about the special symbols like the arithmetic operators. We talked about special symbols like word symbols, so the comma, the semicolon, the question marks, and so on. And then we have special symbols that come in the form of the operators. So in this case, we have the relational operators, which we discussed during our algorithm and flowchart class. Okay. Now, the second category of tokens we have are the reserved words. Okay, the reserved words. And then we'll talk about identifiers, we'll talk about data types, and then we'll look at operators, variables, and constants. Okay, so I'll switch from the handout to the document I shared with you, and then we can pick it up from there. Okay. So that document is titled The Elements of, or the Basic Elements of Programming, okay, but with emphasis on the data types, okay. So we start with data type, which is also another element of programming, okay. Now if we remember from our algorithms, okay, we talked about the fact that there's always a need for data, okay, when you are writing a program or when you write a program. And when we looked at algorithms, we said the algorithms takes in inputs, okay, and these inputs come in the form of data. Now, data basically is a piece of information that we deal with in the process of problem solving. Okay, it is an essential part in programming, okay, because data comes in so many forms. Okay, even as we speak now, okay, data comes in the form of you joining, okay, this Zoom as a participant. It can be considered as a form of data, okay, even with your names showing in the participant list. Hello, can you all hear me?
Yes, sir.
Yes, sir.
Okay, I think I went off. Okay. All right, so data can come in so many forms. Like I said, it can come in the form of zeros and ones. It can come in the form of numbers. It can come in the form of in so many forms. Okay, so there's this image here which I got online just to describe how data can be represented. Okay, so in terms of programming, data can come in the form of integers. Okay, so integers 0, 1, 2, integers in the terms of positive and negative whole numbers. Okay, then data can also come in the form of real numbers. Okay, now if we talk about real numbers, we are talking about, we also call them decimal numbers or floating point numbers. Okay, now these are numbers which have decimal points or precision. Okay, so as you can see here, then we also have data in the form of character. So characters are the numbers, characters are the letters that we have. So A, B, C, up to Z. Characters can come in the form of digits from 0, 1, 2, up to 9. Characters can come in the form of symbols. So the plus symbol, the minus symbol, equal to symbol, question mark, and so on are all considered, or they are all considered as characters. Okay, so for instance, the symbols we see on the keyboard, okay, are considered as characters. The numbers from 0 to 9, the alphabet or the letters from A to Z, okay, and other symbols. Then we have strings. Okay, strings are combination of characters. A combination of characters. So if your name, for instance, can be considered to be a string. Okay, so when you combine characters, your name can be considered as a string. The course code of this particular course, CPS 213, 103, CPS 103 can also be considered as a string, okay, because it's a combination of characters. Now, if we say combination of characters, a space is also considered a character. Okay, that's how come we have space bar on the keyboard. On your laptop or your PC's keyboard, there's a space bar. Anytime you hit it, it gives a space, which is also considered as a character. Okay, so when you combine those characters, you get a string. Then we have a Boolean. Boolean being true or false, data in the form of true or false. If it's not true, it is false. Okay, if it's not yes, it is no. If it's not 0, it is 1. Okay, so those are Boolean data types. Then we have what we call the date and time. Okay, now the date and time varies depending on the programming language that you are implementing. Okay, so that is also a data type. Then if you can see here, we have what we call array, two-dimensional array, and then records. Okay, now we'll delve more into arrays, getting to the latter part of the course. Now, basically, arrays are used to hold combination of data of the same type. Okay, so it can also be seen as a list. Okay, a list of data of the same type. So if I want to hold integers, okay, about 10 integers, that collection of 10 integers can be considered as an array. If I want to hold 10 names of students, where the names of students are all considered to be strings, then that name or those names of students or that collection of names of students can be classified as an array. Okay, if I want to hold, let's say 10 characters, that those 10 characters as names also can be considered as array. Okay, so those are basically what we term data type. Two-dimensional arrays are also there, and then there are records, okay, which is also a collection of elements. Now, records usually hold different data types, different values of different types. Okay. When we go forward, we'll look at this in terms of C++. In C++, we can represent the records in a form of a structure or a class. Okay, so we'll talk about that going forward. So this image here just gives you a brief idea of how data can be represented in programming. Okay. All right. Now, so from the image that we just saw, just a moment. So let's continue. So the data types, like we saw, are classified into two. Okay, they are classified into two. If you go into the handout, you see it. Now, they are classified into what we call the simple data types. Okay, now this simple data type are also called the primitive data type, okay, or the predefined data types. Okay, then we also have the structured data type. Now, the structured data type are also known as the secondary data types. Okay, secondary data types. Okay, so you learn more of the structured data types in data structures and algorithms. Okay, you learn more of them there, but in this course, we'll focus on only the arrays, which is an example of the structured data type. Okay, but the others, the 6 that we have on top here, are considered to be what we call the primitive or the simple data type. Okay, so the next slide is talking about the primitive or the simple data types. Now, they are mostly in a numeric form. Now, if it's numeric form, they have 2 types. We have the integers, which are the positive and negative whole numbers, and then we have the floating point numbers, okay, like we saw from the image earlier. Then we have the characters. Now, these characters in C++ programming, they are enclosed by what we call the single quotes. Okay, so you can see A being in a single quote. Okay. you can see another character, plus, which is in a single quote, and you can see 5, which is also in a single quote. Okay, now anytime you want to represent a character, this is how you represent the values of the character, by putting them in a single quote. Now it is a character. Once it becomes more than a character, then it is a string. Okay, once it becomes more than one character, then we call it a string. Okay, so anytime there's a character, it has to do with just a symbol, okay, or a digit or an alphabet. So we have 5 here with a single quote. This 5 is no longer considered to be a number. Rather, it is a character because of the single quotes over here. Okay. Now, then we also have the strings. The strings are enclosed by the double quotes. Okay, the double quotation mark, as you can see here. Okay, so a string is a combination of more than one character. Okay, more than one character. So over here, you can see programming. You can see ME 30. Okay, with a space there. Like I said, a space is also a character. So combination of characters. Your name can be considered as a string. The course name, Fundamentals of Computer Programming, can also be considered as a string. Okay. And so on. Okay. All right. Then finally, we have here the Boolean, okay, which is named after the mathematician George Boole. Okay, so Boolean are true or false statements, or yes or no statements, or 0 or 1 statements or values. Okay. All right, so let's go through this. Like we always do, if you have any question or if you have a response, kindly raise your hand and then I'll let you respond to it. Okay. Now, for now, let's work on this practice. Okay, let's work on this practice. So I'll pick people at random. Matthew, your hand is up, but I'll plead with you to lower it for now so that I'll pick people at random. I want to tell whether people have not joined the Zoom and they are sleeping, or they have joined and they are actually following the Zoom session. Okay, so just a moment. Okay, so let's continue. So the first one, the data is 17. Okay, so I'll call at random one person to tell us whether that 17 is an integer or a floating point number, or it is a character, or it's a string, or it's Boolean. Okay, so let me look through the names. Let's start with Christian JB. Christian JB. Christian, are you here? Okay, Christian is not here. Let's move to
Yes, sir.
Christian. Okay. So Christian, the first data on your screen, what type is it? We've mentioned 5 types so far.
It's an integer.
It's an integer. Okay, that's good. Let's move to the next one. So who can I take from here? Michael Apedo. Michael Apedo. Is he Apedo? Michael Apedo. There is Michael Agbeni. Okay. It's a string. Okay. Okay. I was actually referring to another Michael. He's Apedo. All right. So let's move to the next one. So the second one is a string. The third one, who can we take? Let me look for a lady. I saw Lucy somewhere. Lucy Saki. Lucy Saki. Lucy Saki. Okay, if Lucy can't hear us, let's listen to Philip Nano. Philip Nano. Philip Nano. All right, Elton Clinton. Elton Clinton. Hey, people have just logged in and
Sir, it's an integer.
I'm sure they are doing their own thing.
Sir, it's an integer. The third one.
Please, who is Zoom user? Kindly rename yourself. Let's know who.
Sir, I'm Elton.
No, someone is
I'm-
named Zoom user.
Okay.
Please rename yourself.
Okay,
Rename
okay.
yourself. Yeah. Yes, Elton. Elton, speak. We are listening.
Sir, it's an integer.
Why do you say number 3 is an integer? What is an integer?
Hello?
Yes, we are listening. All right. Daniel Odro, your hand is up. Can you try?
Yes, I can hear you.
Yes.
This is a floating point number.
Yes. So number 3 here is a floating point number. Now we said the floating point numbers, they are also called real numbers. And they are usually numbers with decimal points. Okay, usually numbers with decimal points. That is what we call a floating point number. Okay. Now let's go to number 4. Number 4, let me look for a lady, Angela Owusu. Angela Owusu.
Angela AJ.
No, Angela Owusu. Angela J, you want to answer the question there? Okay, let's listen to you, Angela J.
It's a real number.
It's a real number. Okay, a floating point number. Okay, thank you. Let's move to question number 5. Question number 5. Oh, Angela, also, do you want to answer question number 5?
Sir, please, I'm having a bit of like challenges with my laptop. That's why I couldn't answer.
Okay, so do you want to attempt number 5?
The screen is even gone off.
Then maybe I can say it so that you tell us what data it
Okay.
is. So the data there is -25.
Sir, please, it's an integer.
It's an integer, that's correct.
Yes.
Okay. So integers are positive and negative whole numbers.
Yes, please.
Okay. All right. Let's go to question number 6. Go to question number 6. Who do I get? Abdul. Is it Abdul Nasir?
Yes, sir.
Yeah, Abdul Nasir.
Number 6 is a character.
It's a character. Great. So number 6 is a character. Okay. Now we are going to the interesting part. Let me start with those whose hands are up. Daniel, you've already answered. So let me take Stephen Nati. Number 7.
Sir, please, it's a string.
It's a string. Are you sure?
Yes.
What did we say strings are? How did we characterize strings?
So you said the string, it consists of maybe multiple of
More than one character.
either a character.
Mhm. And then there was something significant we also said about strings. What is that?
Yes. They are represented by two
You have the slide, so you have the slide. It's in the chat, so you can always look at it.
yeah. So please, the string, you said it's a combination of more than one character.
And then
And
there was
also is represented
by
2 quotes.
please, you said
it's represented
2
by
quotes.
yeah, 2 codes.
2 what?
Code.
Code.
Double quotes.
Please allow him to respond to Abraham Soa. Please allow him to respond. By 2 codes.
So you said
Or
it's,
2 quotation
yeah.
marks. So number 7.
Yes.
Based on the description that you gave to us, you think number 7 is a string?
Sir, please,
Is that
no.
your final answer?
No.
Is that your final answer, Stephen?
Yes, sir. It's not a string.
Then what is it? So, and we have to change the class names to who wants to be a millionaire. When people give the answer, we tell me that is their final answer. Stephen, if it's not a string, then what do you think it is? All right.
So it could be an array.
Hey, you are going too far. Let's listen to Salifu Amadu. Amidu.
Yes, sir. Yes. So the number there is 4.32 expo minus 6. So it's an actual number and it is a double or a floating number.
It's a floating number. It's a floating
Yeah.
number. Okay.
Exactly.
So the E here means exponent 6. Okay, so 4.23 exponent -6. That makes this a floating point number. Okay, that makes this a floating point number. So even though there's an E here, which we consider E to be a character, once this particular data is not within the double quotes or the double quotation mark, it is not a string. Okay, so take note of that. Then here we have number 8. Let's listen to Ruben. Ruben, your hand is up. Okay, if Ruben is not ready, let's move to Fred. Fred Banser.
Sir, please, it's a string.
Yes. Okay, so number
It's a string.
it's a string. Okay, because
Yes.
of the double quotes, even though the value there is a decimal value, okay, or a floating point,
Yes.
because it has the double quotes, it is no longer a floating point data, rather a string. Okay. All right. So let's go to number 9. Let's take Daniel Odro, you've answered. So let's go to Abraham Soa. Abraham Soa.
It's the bool type. That's the logical type.
Okay, it can be considered as a bool type and also be considered as a number, okay, or an integer. The same applies to number 10 as well. 1 can be considered as a bool type or as an integer. Okay. However, when we go forward, you realize that when we start writing the program, we'll be using more of the phrase true and false. Oh, sorry, the word true and false rather than 0 and 1. Okay. All right. So that was a good attempt there. Okay. Now let's continue and look at constants and variables. Constants and variables. Just before that, let me just share with you something quickly. Can you all see the whiteboard?
Yes, sir.
No. Yes, sir.
No.
Yes.
All right.
Yes, sir.
Yes, sir.
Yeah.
For the numeric values, we said they are in 2 forms, right?
Yes,
There's
sir.
the integer, and then we have the floating point. Floating point. So the integers in C++ programming, we use the word int. Okay, so anywhere you see int, it means we are talking about integer. Okay. Now, when you come to floating point numbers, we have the word float. So anytime you see float, it means we are talking about floating point numbers. And then also there's what we call double. Okay, now this is well explained in your handouts. You see it in the handouts clearly. There's double, and then there's long double. Okay, now even with the integers, there's short, there's long integer, there's short integer, there's signed and unsigned integer. Okay, because the integers can be positive and negative. Okay, so there's short and there's even byte. Okay, there's even a data type called byte when we are looking at the integers. Okay, now for all of these data types that have been stated here, they are all integers. Okay, but they represent a particular length of numbers. Okay, they represent particular length of numbers. So there's the long int, which are integers that are very long. Okay, then there's short, there's int, but mostly we use int to represent almost all of them at every point. Then we have float, double, and long double. Now the main difference between the float and the double has to do with what we call the precision. Okay, precision. If we say precision, we are looking at the value after the decimal point. Okay, the number of values after the decimal point. Okay, so mostly floats takes values which are more of less than 6 decimal places, you can use floats. Okay, or we use floats for them. Okay, however, you can also use double to handle those values. Okay, now double usually spans between 6 to 15 decimal places. So values that are more like 6 to 15 decimal places, you use double. And then for the long double, they span from more than 15 decimal places. Okay, that's when we use long double. Okay, however, floats and double can be used interchangeably. Okay, we'll come to why there's that difference shortly. All right, so let's continue. So we have characters, okay, or character. Now, character is represented by the word char or car. Okay, char or car, C-H-A-R. So anytime we want to write a character in a program, we start by using the data type char or car. Then strings are the same as strings. It doesn't change. Then we have the Boolean, okay, which uses the data type bool to represent them. Like I said, the other types that we saw in the image going forward, we will look at them like the arrays and dates and so on, how to represent them in the program. Okay, but at the moment we are focusing on what we call the predefined or the primitive or the simple data types. Okay, all right. All right, so any questions so far on the data types? I'll take 2 questions and then we'll move on. Any questions on the data type before we look at constants? Daniel Amati and Daniel Udro, do you have a question or your hand is just up?
Yes, sir.
Daniel, you have a question?
Yes, please.
Okay.
Sir, the chart that we were answering, either it's a integer or it's in that table.
This table.
Yes, please.
Mm-hmm.
You see the number 7.
Yes.
I was a little bit confused there because when I remember I was learning about binary system and I saw letter representing a number.
Mm-hmm.
So I thought maybe the E there is representing a number.
No. So yeah, I get what you are driving at. So yeah, more like when we are working in hexadecimals. Okay,
Yes,
hexadecimals, I think we represent the E should be 15 or 14 or so. Okay, so this E here is not in terms of hexadecimals. We are looking at binary values. Sorry, we are looking at decimal values, okay, not hexadecimal values. So the E here simply means exponents. Okay, so this is just trying to say 4.32 times 10 raised to the power -6. Okay, so that is what
exponent
is
6. So.
Exponent, yeah, -6. So in that case, that means you are counting to the left, okay, from the decimal
side.
point. Okay, 6 decimal places. Okay, so that's what the -6, E -6 means there. Yes, Peter Boydu, your hand is up in the chat. Do you have a question?
Osana, it has been solved. I'm okay now.
All right. All right, so let's go on. Let's look at constants and variables. Okay, now constants are values that never change in a program. They never change in the program. Okay, whereas variables are values that can take different from, or that can take different values. Okay, so for instance, a constant 6, 5, 62 point something, and so on, they are all seen as constant. So we can see some examples here. Now, if we take this expression, I is equal to j plus 7. Okay, which one do you think is the constant in this expression? I is equal to j plus 7. Michael.
7.
Okay, Shaibu has just answered. So 7 is the constant. Okay, 7 is the constant because the value cannot change. It's fixed. Okay. However, when we take j and I, the values of j and I, or j and I are variable, so they can take values of different forms. Okay. J can be 0, 1, 2, 3, all the way to infinity. Same applies to I. Okay. Now, if we take this example here, which says first underscore letter is equal to, just a moment. All right, so let's continue. So we are saying that the variable I and j can take values of different forms. Okay. Now we have another one here. First letter equals A, where A is a character here. Okay, so what is the constant here? What is the constant here? Yes, Ruben.
First underlet.
Pardon?
First underlet underscore letter.
Are you sure? Let's take another
Yes.
response. Obin Luis. Pardon?
It's A.
A. Why do you say it's A? Can you tell us?
Because the product of the first letter is equal to A. So it means that A is whatever that is in the first letter. So it's not going to change. The product of first letter is equal
The value
the value of first letter A.
is A. Thank you.
The first letter is equal to A. Yeah.
Okay. So A here is a constant. Okay, so it means the value is not going to change. Anytime you assign, I think the last time I talked about the equal to sign when we're doing the algorithms, that the equal to sign represents assignment. It's an assignment operator. Okay, so if you assign a value, we are saying that the first letter should be assigned a constant value of A, or small letter A. So A here is the constant, whereas first letter is the variable. Okay, first letter is the variable. All right, so that explains the variable part as well. Now it says that variables in C++ must be declared before they are used. Okay, so we will look at that in a moment. All right. So what does it mean by declaring a variable or declaring variable? Now in C++ programming, before you use a variable, okay, before you use a variable, the variable must be declared. Okay. Now before that, let's just talk about variable names or identifiers, and then we'll come back to declaring of variables. Okay. Now, let me start by using the generic name, which is identifiers. Okay, now if you go to the handout, it's used, or it says identifiers. Okay. Now, it's one of the category of tokens. Okay. It is, or identifiers are names that appear in the program. They are names that appear in the program. Okay. Now, these names are in the form of variable names. They are in the form of constants. They are in the form of functions. Okay, function is one of the topics we look at as well. Now, our emphasis now is on variables and constants. Okay. Now, a typical example of an identifier, okay, being in the form of a constant is the value pi, okay, area of a circle, pi r squared. That pi there is an identifier, but it holds a value of 3.14. Okay, so we also know pi to be a value which doesn't change in the program. Okay, so pi is always 3.14. Okay, so the variable or the identifier used to handle that value for pi, okay, is the word, or is the word pi. Okay, now identifiers are also considered, or variables are also considered to be identifiers. Okay, now in terms of using identifiers or variables, there are some rules that must be followed. Okay, there are some rules that must be followed. Now it says a C++ identifier consists of letters, digits, and underscore. Take note of this. Take note of these three: letters, digits, and underscore. Now, if I say letters, we are looking at letters from A all the way to Z, either uppercase or lowercase, letters A to Z. Now, digits are, let me just show you something quickly. Okay. Can you all see this keyboard on the screen?
Yeah.
All right.
Yes, sir.
Yes,
If
sir.
we are talking about letters, we are talking about all these. We are talking about all these letters that we can see here. Okay, A all the way to Z. These are letters. Okay, whether uppercase or lowercase, these are all letters. Okay, when we talk about digits, we are looking at the values here: 1, 2, 3, all the way to 0. Okay, these are digits. That means it doesn't mean that it should be only one digit. You can combine the digits, okay, as long as you whichever way you want it. Okay. Then the only symbol that identifiers can take is what we call the underscore. Okay, the underscore, which is this one. This is the only symbol identifiers can take. Apart from that, any other character, or any other symbol that is being used will result in an error in your program. Okay, so the only symbol that your identifier can take is the underscore. You don't use dot, you don't use full stop, you don't use question mark in in your identifiers or variable name when you are naming your variable. Okay, the only symbol that is allowed is the underscore. That's why it says in C++, identifiers consist, okay, consists of letters, digits, and the underscore. And it must begin with a letter or an underscore. Okay. But mostly, it's best when you begin with a letter. Okay. Now it says some identifiers are predefined, okay? Others are user-defined. Now, if you say an identifier is predefined, that means it's already inbuilt into your program. A typical example is what we saw last week. That's the cout. The cout is an identifier. However, it is predefined. Okay, it already exists in the program. It is predefined. Okay. Then we saw another variable, which is num. Now, this num is a user-defined. So instead of number, I decided to write it in short, num, N-U-M. Okay. Now, there are two predefined variables that we will encounter frequently. We have the cout and then the cin. Like I said, the cout is for output, cin is for input. Okay. So that is it. Now, a typical example of legal identifiers in C++. So we have first, which is correct. A is full of letters. Then we have first name. First name. Now you can see here, someone would have said, okay, first, let me just demonstrate this quickly. So identifiers or variable names. So okay. Trying to locate my let me just wipe this off. Okay. So we have first, okay, first name, then first underscore name, then first name, then first dot name. Okay, so these are three different scenarios of an identifier. Three different scenarios. Okay. Now this one, which is first name, has a space in here. I believe you can all see. Can you all see the space there?
Yes, sir.
Yes, sir.
Yes, sir.
So it has a space here. Now that space here makes it invalid. Okay, so because of the space in here, it is no longer a variable name or an identifier. That's to say that when you are writing variable names, you don't leave space in between the variables. Okay, so this over here, the first one, first name with a space, is wrong. Doesn't qualify to be a variable name. If you use it in a program, you have an error. I quite remember there was this time, one of the exams, they were supposed to create a project. And in Java, when you are creating your project or your class, the class name, which is an identifier, follows some of these rules. And for over 30 minutes, this guy was sitting there saying that the IDE was faulty, or the machine is faulty. The IDE is not working, the machine is faulty. So over 30 minutes, people have started their work. This guy was still there. Only for me to get there and realize this guy was using the wrong naming for his class. Okay, or the variable name was wrong. He was typing the word and had a space in between it. So because of that, when he pressed enter, the enter key or the enter button is not working. And this guy has been sitting there complaining that his PC is not working for over 30 minutes. Why? Because of what? This issue with variable names. Okay, so please, you don't leave a space there. It's either you join them together or you use an underscore, like I've done in this case. Like I said, the only symbol accepted is an underscore. You don't use a dot. If you use a dot, it's wrong. It will give you an error. Another example, instead of first name, you are starting with what? Number 1, first, and then name, which is also wrong. From the material we just read, it said you can only start with a letter or an underscore, okay, but preferably a letter. Okay, so please take note of that. Samuel, your hand is up. Do you have a question? Samuel, do you have a question?
Yes, please.
Yeah, go on.
Yes, sir. So, with the underscore, does it come before when you are naming a variable and say A? Does it come before the A or it comes after A?
It can come anywhere in your variable. So usually we use underscore when whatever you are trying to describe is it's made up of 2 words. Okay, it's made up of 2 words. So for instance, a word like first name, there are 2 different words. But because we are not supposed to separate them with a space, we use the underscore to more like make it a bit readable. Another way in which people write this, let me just open the IDE and demonstrate this to you. So there's first underscore name. Okay. You can write first. Now, if you bring it,
how do you go about it?
Okay. So let's say yes, were you saying something, Samuel? All right, so let's continue. So the first and then the name. Okay, so it's either you use the underscore like we can see in 1, or you use the second letter is made readable in this form. Okay, but never leave a space between them. Let's say first name. Okay. Never leave a space.
Okay, sir.
Okay. Then you don't start with a number. The number can be in between or can end it, like we can see here. Counter 1. Okay, you can see here payroll. These are 2 different words. Pay rate. 2 different words. Pay and rate. Okay, so someone can decide to say pay underscore rate. Okay. Someone can say pay rate. Someone can also say pay rate, or in lowercase. Okay, so these are all variable types. Variables. Okay, but can be written in different form. Okay, however, some of the rules are outlined, govern it. Okay, now these are some of the rules. It said C++ is case sensitive. Uppercase and lowercase are considered different. That means that if you type an identifier number, it is not the same as when you type it in this way, small number. It's not the same. Okay, we saw that when we're doing the algorithm. Similarly, when you do capital X and small x, they are not the same. Okay, they are not the same. Please, if you hyphenate it, hyphen is different from underscore. Okay, Griffith. Hyphen is different from underscore. Like I said, the only symbol that is accepted is an underscore. So if you hyphen, you use hyphen to give you an error. Okay, read one entry. Your hand is up. You have a question. All right, so the next point says identifiers can be of any length. Can be of any length, but you should keep it to 31 or fewer. Okay, you should keep it to 31 or fewer. In some other books, they'll say 63. But your identifier or your variable name shouldn't be that long. Okay, the longer it is, the easier it is for you to make a mistake, an error in the program. Okay. Then also, it must take some unique characters, numbers, or characters that are unique, that explain the type of data you want to take. For instance, you can't use a variable named age when maybe you are going to take index number of a student. Please, are we all here?
Yes, sir.
For instance, I want to take index number.
Yes, sir.
Instead of using index number, I use age. And I enter the index number of people, which is wrong. Okay. Or I want to take date of birth. Instead of date of birth, I use a variable named age. The variable name should be unique to whatever type of data you are taking. So if I'm taking age, I know age should be, say, 1 year, where 1 is 1 year, or 25. Age is equal to 25. That means the person is 25 years. If I'm taking index number should have a variable name, index number in this form, or another person can choose to say index underscore number. Okay, so these are ways in which you write variable names. Then it says the initial character cannot be an integer. That means you shouldn't use an integer. And then avoid using reserved words or keywords as identifiers. Now, last week we talked about reserved words, C++. Okay, if you go through this the slide, I think the last but one slide, you should see the reserved words or keywords in C++. So these are the reserved words in C++. And it says here that you cannot use these words as variable names. So the reserved words break, double, int, float, default, go to, size of, volatile, while, if, do, case, enum, register. These are all reserved words. You can't use them as your variable names. Else it will conflict with the program and give you an error. Then it said avoid the use of runtime libraries. Now we'll look at these runtime libraries. When we look at it, I'll explain to you what they do. One typical example is what we call the math library, okay, or .math. Now this .math library, what they do is that they hold functions. So if you want to do some mathematical computation, you don't need to write the formula, okay, or sometimes it's difficult writing the formula. So all you do is to get the function that will help the programming become simple. Just like in Excel, if you've used Excel before, okay, and you have, let's say, about 100 cells of numbers you want to add, You don't do cell 1 plus cell 2 plus cell 3 plus cell 4 all the way to cell 100. Rather, there's a function known as the sum function. You just use the sum function and then you select your entire cell and it gives you your answer. Okay, so the same way in programming, there's what we call libraries. Now, these libraries have functions in them which makes programming easier. There are a whole lot of them. Okay, so my assignment for you today is to go and look out for all the libraries in C++ and their respective functions. Not necessarily all the functions. Also, let's say 10 libraries and 10 functions each. Okay, so one of them is the math library. So go and look out for 10 libraries in C++ and 10 functions in each library. Okay, let me just show you, give you a typical example of what I'm talking about in Excel. Okay. Just a moment. Let me create an Excel file. Danielson, please stop writing on the screen. Kindly undo the text you've written on the screen. Thank you. All right. So if you can see in this Excel, okay, Excel has formulas. Okay. Now there's the function magnifier to make it bigger for you to see. There's the function library. Okay. Now there's a financial library, logical library, text library, date and time library, maths and trig library. Now, if you come to maths and trig library, it shows you functions within that library. So there's ABS, which is absolute value. There's ACOS, and so on. Cos, sine, decimal, converting to decimal, even, greatest common decimal, CDF, greatest common divisor, sorry, GCD, there's log, okay, a whole lot of function in here. Anytime you want to perform something regarding mathematics. Okay. Now the same applies to programming. Okay. If you want to do some computation which requires some math function which you can, writing the formula will take a long time. Some functions are inbuilt or predefined, so you use them as and when you encounter those challenges in your program. Okay, so what it's saying here is that you don't use those functions. Okay, you don't use those functions or those runtime libraries as your variable names. You don't do that in your program. And then lastly, you don't use try not to use uppercase, okay? Because the uppercase can be considered as what we call macro names. Okay, we call them macro names. So try as much as possible to use lowercase for all your variable names, just like I'm doing here. You can see that I start with a lowercase. Okay, so your variable names, always try as much as possible to use lowercase for them. All right, there's some question in the chat, I guess I said. Yeah, I read one. You are saying that, so the first name you can put underscore there. Yes, you can put underscore there, but to be on the safer side, just use the first starting with the letter F, or spell the first, okay, and do it first name, rather than starting with an underscore. There are times the underscore might end up giving you an error. Okay, depends on the editor or the IDE you are using. All right, so let's go back to our document. We'll be ending shortly. So those are variable names. There are some example here. Try it on your own, whether it's valid or invalid. Okay, so if it's valid, why do you think it's valid? If it's invalid, why do you think it's invalid? Okay, so give some comments to it. All right, so earlier on, we talked about declaring variables. Now, variables and data types, okay? Now, when you are declaring variables, it means that you are trying to define the variable, okay? Trying to define the variable. Now, it says here that how many bytes of memory set aside. That's what it's trying to look at. And how to interpret the bytes as in terms of data, okay? Now, this is an example of declaring a variable. You declare, when you're declaring variables, there are two things involved. There's the data type that you designate to that variable, and then there's the identifier or the variable name, okay? So if you look over here, in declaring the variable, there's a data type first before the variable name. The data type, the variable name, data type, variable name. Now, the data type will signify the type of value that variable should hold. So if we say int, the variable name is my var. Now, that means that we are declaring an integer variable, my var. That means that my var, which is a variable, and like I said, a variable is more like a container, okay, which is holding values or a place in memory. A container or a place in memory. So for instance, I have something like this. So let's say this is your memory, okay, or a container inside your machine, your memory. Now, if you declare a variable, that means that this position here should now be assigned to your variable, my var. If you declare another variable, another position or location in memory will be assigned to it. If you declare another one, another position in memory will be assigned to it, okay? So you are saying that this first one, which is the my var, should take an integer value. Then the next one, which is sensor one, should take a floating point value, which is float. Then the next one, which is char letter 01 underscore A. Now this letter 01 underscore A is a variable name. And the data type here is char. Okay, so that it means that the letter 01 underscore A should take a character value or a char value. So that is it for declaring of variables. Now, when you go a step further, we call it initializing the variable. So initializing the variable is when you now assign value to the variable. For instance, when you now say that int my var is equal to 10. Then we say you have now initialized the variable. Why? Because you have assigned a value of 10 to the variable. So in this case, it's going to store the value 10 over here in memory. Okay, inside your memory. So we are assuming this is the memory. So it's going to install or going to keep your value 10 inside the memory. Okay. If we say float sensor, and let's say we assign a value of, let's say, 7.2, that 7.2 will be kept here in memory, 7.2. Are we all here?
Yes, sir.
Yeah.
Yes, please.
Yes, sir.
All right. Any questions?
Be alive and
Today, I don't want to go very fast since we have the part-timers in our midst. They have to join another class. So I'll end here and then take questions from you whilst you go through the slides. It's 23 slides. I've done only 7. Okay. Let me just skim through it quickly. Okay, so variable names, we've looked at this already. Try this out. Then the data type and memory. Then the memory allocation. So I mentioned some of the description, char, short, int, okay, and the memory. These are 2 different, what do we call? These are 2 different compilers. Okay, so there's the AVR GCC compiler. There's the MSV C++ compiler. Okay, 2 different compilers. Now that's to say that if you use int, one of the compiler, int is taking 4 bytes of memory. So if you say int my var equals 10, for this compiler, that's my var equals 10 is taking 2 bytes. However, this one is taking 4 bytes. Okay. Now the value range for each of the data types have also been given here. Okay. Now you remember I talked about float and double. Float and double. Float is for a single precision floating point number, while double is for a double precision floating point number. Okay. Now, if you use double or float for one of the compiler, double and float are taking the same bytes in memory. Okay. However, for the other compiler, the MSV GCC compiler, which is more of the compiler that we are using now, float is taking 4 bytes in memory, whereas double is taking 8 bytes. Okay. That is to say, like I said, you can use double and float interchangeably. Okay. But in terms of C++, you look at the value that you are going to handle, and that should determine whether it's going to be a float or a double. Okay, so if the precision is more than 5 decimal places, then use the double. Okay, however, if it is less than that, so you have something like someone's salary, so 1,000 Ghana cedis, 52 pesos. So that's 1,000.52. 1,000.52, there are 2 numbers after the decimal place, okay, which qualifies as a single precision. Okay, so with a single precision, a float would be okay, because that will give you 4 bytes in memory. However, when you use double, double will give you 8 bytes in memory. Okay, so it's advisable you go in for the float. It's advisable in that particular example. Okay, so that is it. Then declaration also explained here. Operators. Okay. Operator precedence and associativity. I explained them in the class when we talked about the board masking. Okay, so this part of the slides explains it further. Then this is the table. I talked about the precedence, meaning that some operators have higher precedence than other operators. Okay, so in that case, some operators have higher precedence than other operators. Okay, and then some are of the same precedence. And we said if they are of the same precedence, this rule of associativity comes in. Okay, and then we said the rule of associativity, we have the left to right and right to left. So if you look at the table here, the table shows the operators, C and C++ use the same operators, okay? So you can see the operators, now they are in order of precision. Like we always say, bracket first or parenthesis first. They are in the order of precision, Okay, these are all the operators you can get in C program and C++ programming. Yeah, in the order of precision. Okay, now if you look here, the arithmetic operators are here: multiplication, division, modulus. Okay, and like I said, the associativity, because they have the same precedence or priority, they have the same priority, you handle them from left to right. Then the next in terms of the order of priority after the multiplication, division, and modulus is addition and subtraction. However, the highest of the precedence is the parenthesis or the brackets. Okay. Then we have the postfix, prefix, and so on. So you can go through this table, have a better understanding. Okay, then there are some practice examples here being explained. And then we have what we call the specifiers. Okay, this has to do mostly with C programming, so you can skip it. But the escape sequence, you remember last week we talked about the end L. And we said that when you want to move to the next line, you use the end L. Okay. So there's what we call escape sequence. We'll be using it a lot when we start programming, hopefully from next week. So there's one here, which is the \n. When you want to move to a new line, you use the \n. Then we have the \t, which is horizontal tab. Okay, we'll be using those two a lot in our program. Okay, we call them the escape sequence. So you should know them. If you want to use \, you already know that the double / in our program is for what? A single line comment. Okay. However, there is another way of using this double / to give you a / when you want to output. This escape sequence are always used when you want to output. So we will explore them further. Then this has to do with memory, how values are saved in memory and all that. Now we'll look at pointers. Okay, and when we look at pointers, it will explain this particular portion of the slide very well. Okay, on how values are saved in memory. Okay, and then we have the reserved words. And then the ASCII table I talked about when we're talking about the, what's it called? The evolution of programming languages. Okay, so this is the ASCII table. All right, so that's it for today. If you have any question, I'll take
Thank you, sir.
5 questions, and then we can call it a day. The videos will be uploaded and the link shared with you. Okay. Yes, Christian. Hello, Christian. Okay. Any question? So the basic element file, Emmanuel Dankwa, is being sent to your class reps. They have a platform, a WhatsApp platform I communicate and share information with. So they will do that. They will share it with you on your respective platforms, both the morning and the evenings, the full-time and part-time. Yes, any question? So I want to assume that today's lecture is well understood. Okay, we need to understand these basic elements. Once we understand them, next week we start writing our programs, and then I'm sure you will flow.
So please, where should we do the assignment?
Or just do it in your notebooks. Just do them. One thing I do, anytime I tell you to try something, please just try it. Okay, you don't know when it will appear again. Maybe in exams, in mid-semester exams. I might not come readily to inspect it. Okay, but when you try them, it helps you. Okay, so please do your best. Try them, whatever I tell you to try, the table, the variable, the libraries, and all that. Okay. Yes, someone's hand is up. If you have a question, just raise your hand. Okay. Just like we do for our face-to-face. All right, so in the absence of any questions, let's pray and then end today's.
Sir.
If you have a question, kindly raise your hand. It's easier to address it that way than saying say.
I know what they told you, but you got me fucked up.
Yes, Joel, you can ask your question. I'm only taking the 2 questions. Kingsley.
Please, can you go over? My connection went off.
Don't worry, when I share the video, you
Sir.
get all the information. Okay.
About the assignment.
When you watch the video, you get all the information. Yes, Kingsley.
So please, during your lectures, you're like, before you declare a variable, you need to first, like, first need to type your data type or something.
Yes.
So without that one, you can't declare the variable.
Yes, in C++ programming, without the data type, you have not declared your variable. Okay, so it should always be 2 things, your data type and your variable. Once you have them together, then it means you've declared your variable. Yeah. Yes, let's take the last one.
Okay, sir. Thank you, sir.
Edwin Cranton.
Yeah, hello, sir. Please, can you hear me?
Yes.
Okay, so please, I was asking with the variable naming practice, the one you said we should try our hands on.
Yes.
Yeah, I was saying, like, can you help us maybe go with the first one so we know how to go about with the rest? Maybe with the first.
So the first
bump. Yeah.
The first line says, is it valid or invalid? I think so. So the first line is bump switch. Okay. So valid or invalid. So I put the valid. So if it is valid, why am I saying it's valid? It's valid because instead of the space in between the bump and the switch, we are using an underscore. You get it?
Yes, sir.
So that makes it valid. So look at, comment on the whether it's valid, the validity based on the rules that were given. Okay. The rules are in the handout as well as this material too. The rules are here. Okay, so comment based on the rule and the examples that I discussed. Okay, so you go to the next one. Is it valid or invalid? You state it and then you make a comment why you think it's valid or invalid. Yeah. Okay.
Please, thank you.
All right, you're welcome. Okay, so